So we're now moved up to the winery.
So we're in the shade and it's slightly cooler, so that's nice.
Very slightly. So this is obviously the winery. This is where the grapes are processed and ultimately turned into wine. So what we're going to do is gradually move through the winery, looking at one or two of the different parts of the winemaking process, but from a biochemical perspective. Now there is some activity going on in the winery. We are just starting vintage up here, so there'll be a little bit of background noise and there'll be a bit of activity. That's because it's happening. Sorry, Beth.
We've got third year students coming in to start making their very first batch of wine with various sorts of grapes, some red, some white. So we've obviously got anthocyanin situation going on with the Shiraz, as we saw down in the vineyard, and then we've got some whites as well.
Probably what we'll see today, if we see any grapes at all, will just be white grapes. We picked them this early for making sparkling wine base and potentially for some low alcohol white wine as well. Anyway, this is where the grapes are received in the winery. Then we'll move through now to where they're crushed, and then we'll go on to the fermenters. All right, so we've now moved into the winery and we're in front of the crusher. The crusher's actually outside being cleaned at the moment, but this is where it would be. And in the winemaking process, crushing releases the juices, and depending on whether we're making a white or a red, we then do different things with them. Let's think from a biochemical perspective of what's in that juice. It is, of course, it's a juice, so it's got a lot of liquid. That liquid is water. We talked about the importance of water in the vineyard, and water is equally important as the base solvent, if you like, for wine. The other major component of the juice, of course, is sugar. Glucose and fructose, two simple 6-carbon sugars that entered the berry as a disaccharide. So that's a single molecule made up of 2 molecules of monosaccharide, and then it's broken apart. And we'll talk all about that in an exciting lecture in about week 5.
The key thing to remember there is that the transport sugar for all plants is that disaccharide, which is sucrose. It's a non-reactive sugar, so it can move from the leaves to the berries or wherever else it's going without being broken down along the way.
That's right. So the sugar and the water are the main components of the juice. There are also lots of compounds that ultimately give rise to the flavour of the wine, and also proteins that have come from the berry, and a lot of acid as well, depending on the time of year, depending on the variety. There will also be acids there, because ultimately wine, as a sensory drink, has to have acid to balance the alcohol and all of the other flavours. So it's very important that we not only conserve that composition, but that we understand the composition of the juice after the crushing process. Now, I mentioned acids. Very important parameter here from a winemaking perspective is pH, the concentration of protons. Why is that important? Well, 2 reasons. One is ultimately it has an impact through the nature of the acids that are giving rise to that pH on the taste of the wine. But from a biochemical perspective, the pH determines the reactivity, how reactive an enzyme is or not, of a lot of the biochemical processes that are going on in the juice when a winemaker breaks open the berry and exposes that juice to the air. Now, one of the most obvious of those is a browning reaction. You'll all be familiar with this if you cut an apple in half or started eating a banana and got distracted, and you go back 10 minutes later and it's all brown. That, as you're possibly aware, is due to the activity of an enzyme called polyphenol oxidase. And those enzymes are present also in grape juice, and we do not want our wine to be brown in colour. If it's a white wine, guess what? We want it a kind of white colour. If it's a red wine, a red colour. Brown does not come into the colour of young whites. So winemakers have a specific tool that enables them to stop the activity of that polyphenol oxidase enzyme, which otherwise would run rampant in the juice because of the low pH conditions that the juice finds itself in, and the fact that under those low pH conditions, that enzyme is optimally active. Okay, Beth, so now we're going in the part of the winery where we conduct some of the fermentations, and you're going to tell us all about what that means.
Right. So we've crushed the grapes. They're now a big mess of sort of juice and all the good stuff that was in the berries. and they're now going to go into these tanks to be fermented. So what we want to do in this stage of the process is break those sugars down and convert that sugar into alcohol. So there's a beautiful pathway which you're going to hear a lot about in biochemistry, known as glycolysis. That's the first step of the fermentation process, where we turn sugar as a simple sugar in the form of glucose into a compound called pyruvate. We're going to make some ATP along the way. We don't really need to concern ourselves with that at the moment. But then that pyruvate, in the absence of oxygen, that's the key part of the process. In the absence of oxygen, that pyruvate is going to make its way through a fermentation step and be turned into alcohol. If oxygen is present, that will not happen. That part of the process will not happen. That pyruvate will go off into another pathway. So that is why it's really critical for fermentation that oxygen is not present.
Absolutely. The whole rationale for the yeast's decision whether to make alcohol or not is based on the energy available from the glucose. And just as Beth and I are standing here now breathing air, obviously 20% of that air is oxygen. Yeast can do that equally well. It's a process, I'm sure you're aware, called respiration. When we're breathing oxygen, we can use that to allow for the complete breakdown of glucose or any other sugar, breaking all of the carbon, all of the bonds between the carbons and the hydrogens and the oxygens, and in so doing capturing the energy that they held and using that for other biochemical processes, as we spoke about in the earlier video. If, however, oxygen is absent, then if I'm faced with that situation, I'm going to die. In about 3 minutes, that's the end of me. However, if I were a yeast cell, then I can switch from breaking down glucose and releasing all of its energy using oxygen to breaking down glucose and releasing a little bit of its energy. And a byproduct of that is ethanol. That's why yeast do fermentation, because in the absence of alcohol, in the absence of oxygen, it allows them to stay alive. So it's a really useful little trick. It all goes back to a particular set of enzymes. We'll talk to you about what those enzymes are and how they're regulated. And that's kind of the magic, if you like, of fermentation. And from that process, we convert grape juice through to wine.
And of course, the wine that results will depend on the proportion of those simple sugars that we have managed to turn into alcohol. If we convert all of those glucose molecules into alcohol, then our wine is not going to be remotely sweet at all. So the proportions of these things will then affect the ultimate properties of the wine.
Absolutely. Now, one other thing before we finish. Most of us like our wine to be crystal clear. We don't want it to be cloudy. Now, what we've just talked about, turning the sugar to alcohol, yes, that's happened, but all of those other components from the grape, the proteins, the polyphenols, and various other parts of the grape berry are still there. They're still dissolved in the wine. But the wine is not what the juice was. The juice was water and sugar and other stuff. The wine is water, sugar, if there's any left, but also ethanol, which is a different sort of solvent. As it turns out, proteins are less soluble in a mixture of ethanol and water than they are in water alone. Over a period of time, what that means is that the proteins that have come into the wine from the grapes start to stick together rather than stick to water molecules. And when they get slightly too big, they fall out of solution. We see that as a cloudiness. So you don't want that to happen. The last thing you want when you're opening a bottle of wine is for it to be cloudy, if the wine was intended to be clear. A big part of what the students in the winery here will be doing very shortly when they've made their wines is to get rid of the proteins, because otherwise there is an absolute guarantee that in the short lifetime of that wine, it will become cloudy. Again, it's a consequence also of the pH of the wine, and it's a consequence of the different solubilities of the proteins in the wine compared to when they were in the grapes. So there's a little bit there of the biochemistry of the winemaking process and some of the biochemistry that underpins a couple of the additional stages that winemakers have to do to make a stable product. So now I hope you can see not only in the vineyard but also in the winery why biochemistry is such a fabulous topic. Isn't that so, Beth?
That is absolutely correct, Chris.
Good. Enjoy your course.